Sorry about this. Okay. Here's example 6. Let's go on and blow this up for now. Find the surface area S obtained by rotating the graph of x to the 1/2 minus 1/3 x to the 3/2 about the x-axis from 1 to 3. Okay, so that's the picture of it, which is, I appreciate they've drawn it for me. I would have hated to have had to draw that, but now I've got to shrink back down. And where do we begin? Yeah, y prime is equal to 1/2 x to the negative 1/2 minus 1/2 x to the 1/2. Perfect. Okay. Let's, I don't know, again, I have to stop and think what would be the order of doing this. I think it's probably a little better. Go on and pull out the 1/2 and then have this as being x to the minus 1/2 minus x to the 1/2. Okay, and then what are we going to do with that? Square it. So x prime squared, y prime squared, is equal to 1/4. I can do that part. What, what would be the next part? X to the minus 1 minus 2 times x to the minus 1/2 times x to the 1/2 is just going to be 1, right? So that's a minus 2 plus x, right? All right. Now, silly as it seems, I'm going to multiply the 1/4 back through, okay? So this is going to be, I'm going to put it 1 over 4x, if that's okay, minus 1/2 plus x over 4. I'm not sure that's the best way to do it. But now what do we do? Add 1 to that. So plus 1. Okay. All right, and what's that going to be? But, and now I'm going to go back and rewrite it almost the way I had it before. Okay. And you don't have to do all this flip-flopping around, but it just seemed like to me it made a little more sense. 1/4 x to the minus 1, and you had a minus 1/2 plus 1 would be a plus 1/2, and then you have a plus x, 1/4 x, okay? All right, and what are you going to do with that? Square root of it. Okay, so we're going to take a square root of that. Well, I take a look at that and say I've got 4's in the denominator everywhere, so I'm going to rewrite this as, it's all right to go. I'm going to do a few steps at once. Got 4's in the denominator. I'll make this a 4. Make that a 4 and this a 2. Okay. So, let's take out a 1/2, because 1 over the square root of 4 would be square root of, that would be 2. So that's 1/2. Okay, and then what you have, going to put this in parentheses, x to the minus 1 plus 2 plus x to the plus 1. Okay. I think that's what we, and that, I'm sorry, this part is still to the 1/2. Okay. Now, what do you do with that? Well, what we're looking for is surface area. Find the surface area. I like to say SA rather than S, but it's okay. Because S by itself, to me, even though it's a capital S, I confuse it with arc length, which is a little s. Mine sometimes don't look that much different. So when I'm saying surface area, I put SA, just so I won't get confused. Okay. That would be the integral from 1 to 3. Okay, the 2 pi's out in front. Remember 2 pi. Your F is what you started with. There it is, your Y there, which is x to the 1/2 minus 1/3 x to the 3/2. Okay. And then I have this 1/2, so it's going out front and wipes out the 2 there. And then this part will be x to the minus 1 plus 2 plus x to the 1/2. And then you have your dx. Okay. Now, let's see, we've got everything that looks pretty much like that. Integral, pi times 1 to 3 of 1. Okay. The next thing they do, wait. Oh yeah, sorry. Got the little trick here. If you'll notice, this isn't a whole lot different from what this thing was to begin with, squared. Remember? When we squared this, we made that, which then became 2 over 4. And that looks very, very similar to what we have here. So this might be indicative that this might be a perfect square trinomial. A weird looking one, but still, if that was x to the minus 1/2 plus x to the 1/2, let's square squared. Let's see if we wouldn't get what's up here. Square the first term, that gives you x to the minus 1, right? Plus twice the product here. Sure enough, that's what you got there. Plus this squared is exactly that. So sure enough, this thing right here is a perfect square trinomial, and you take half of that, so you get just that term there. So rewrite this as pi times the integral from 1 to 3 of x to the 1/2 minus 1/3 x to the 3/2 times x to the minus 1/2 plus x to the 1/2. Okay. I think I'm going to erase some stuff because it is beginning to, oh, it's not erasing. It is beginning to interfere with one another. Okay. Okay. All I need is a dx here, and I'll be ready to go. All right. Now, what would you do next? Yes. foil it, okay? It happens to be two binomials, two rather bizarre and awkward-looking binomials, but still two binomials nevertheless. And what do you get when you multiply the first terms? 1. That was not bad. How about the outer terms? X plus X. How about the inner terms? Oops, I usually do that down here. Okay, let me get my pen back. Minus, you got a 1/3 in there too, don't you? Yeah, okay, 1 minus 1/3, and that would be X to the 1, or X, isn't it? Okay, it would be X because 3 halves plus a minus 1 half would be 2 halves, which is 1. And then finally, the last term gives us another minus and another 1/3, and what? X squared. Okay, and all that's going to be dx'd. Okay, yuck. Whoops. All right. So this is going to be pi times the integral from 1 to 3. Okay, we can combine two of those terms, right? 1 yeah, 2/3 x minus 1/3 x squared dx. And then what does that give us? Pi times antiderivative of 1 is x plus second. Okay, which I would think I would say 1/3. All right, 1/3 x squared minus 1/9 x cubed. Evaluate that from 1 to 3. Okay. All right, that's going to be a pi out front, and then you're going to have a 3 plus 3, right, minus, is that a 3? Okay, that last 3 minus 3, I'm going to make a 0 there. Then we're going to have a minus 1 minus 1/3 plus 1/9. Okay. Well, I think I'll make that a pi times 2, and then minus 1/3 plus 3/3 would be plus 2/3, 2/3, which I'm guessing they're going to probably write it as 8/3 pi. That's just a guess. No, whoa, whoa, whoa. No, I did it backwards. Goodness. 1/3 is 3/9 minus 3/9 plus 1/9. Goodness gracious, where's my brain here? Okay, let's get that erased. All right. I was skipping too many steps trying to get everything in there. That was a 2. Okay, and we have a minus 3/9 plus 1/9 would be a minus 2/9. 2 minus 2/9, which will be 1 7/9 pi, which I'm guessing they will do 16/9 pi. Is that more like? Yes, that's what they get. All right, good deal. The hard part there is fractions. That's usually the case, isn't it? All right, so there's a summary, goes over those two big formulas we had here. How about preliminary questions? Worthwhile doing those? Okay, let's do those. Let me clear this. Any questions on this one before I clear it off? Okay. Now, which integral represents the length of the curve y is equal cosine x between 0 and pi fourths? Does this one? 0 to pi fourths, the square root of 1 plus cosine squared x dx, or the integral from 0 to pi fourths of the square root of 1 plus sine squared x dx. Which of those two represents the length of the curve y is equal to cosine x? First or second? A or B? The curve is y is equal to cosine x. Which represents the length of the curve, the arc length? B, the second one. Because the first thing you got to do is find the derivative. The derivative of cosine is sine, then you square it. Yeah, that gives you that. So B is correct. Number 2, that was 1. Number 2, by rotating the line y is equal to r about the x-axis for x in the interval 0 to h, and applying the surface area formula, obtain the well-known fact that the surface area of the cylinder of radius r and length h is given by 2 pi r h. Okay? Let's do a little picture here first. We're going to rotate the line y is equal to r. We'll call this r here. And here's the line y is equal to r. Okay? About the x-axis for x in the interval 0 to h. So here will be 0, and we'll make this h. Okay? We're going to rotate that around the x-axis. Okay? It goes down here. I'm sorry. So that would be okay. That. Okay? This is h here, and this is r here. No. Yeah, y is equal to r. Okay? Now, this is the line y is equal to r. Y is equal to r. Get this in here. Okay. Y is equal to r. And if you take the derivative of that, you get 0. Square it, you get 0. Add 1 to it, you get 1. Square root of 1 is 1. And your 2 pi r, y is r, so 2 pi r going from 0 to h is 2 pi r h. It just seems so almost incredibly simple. I mean, don't you see? It's just there. I mean, I don't know. I guess that was conceptual in some way. So let's look at number 3. If 0 is less than or equal to f is less than or equal to g of x, both of those are functions of x, for x on the interval from a to b, can the surface obtained by rotating the graph of y is equal to g of x around the x-axis over the interval have less surface area than the surface obtained by rotating the graph of y is equal to f of x around the x-axis over the same interval. It's just a yes-no question. Can the surface obtained by rotating the graph of y is equal to g of x, the bigger x, around the x-axis over the interval, have less surface area than the surface obtained by rotating the graph y is equal to f of x around the x-axis over the same interval? Okay? I'm going to give a pretty extreme example here. This is number 3. Okay? Here, of course, is y is equal to 0, right? Okay? And let's have my g of x. That's going to be the big one. This is, it doesn't matter. I'll do a to b. Okay? And this will be just like the one we just did, only we're starting here. Okay? There's that cylinder. What if, this is my g of x. What do we call it before r? Whatever it is. What if my f of x was like this? Certainly a function, right? And you could actually have it go up and touch this. The arc length of this is a lot more than that. So I would say, yeah, you can have more surface area than that. Oh. I drew that poorly. Okay. Let me get that a little bit better. That. Okay. It had to be greater than 0. Okay. So they can touch here because they can be equal, and that can be equal. And again, this has a lot bigger surface area than this one. So yeah, I would say, what's the question, yes or no? Can the surface area obtained by rotating G have a less surface area? And I would say the answer to that is yes. Let's see what they say. This is 8.1 preliminary question. First, yeah, the second one is correct. Third one, yeah, we just did that. It was perfectly fine. And 3 is yes. Very good. Number 4. Use the formula for arc length to show that for any constant c, the graphs of y is equal to f of x and the graph of y is equal to f of x plus c have the same length over every interval a to b. Okay? Well, where would you begin? What's the first thing we usually do? Okay, and what's the derivative of this one? F prime. What's the derivative of that? F prime. So everything else is the same. Add 1 to it. Take a square root of it. But the other, yeah, a to b, it's going to be the same. Yeah. This one down here would be like this, and this one would be like that, but the arc length is exactly the same thing. Exactly. Good deal. I don't know if they go into any detail here. Yeah, all they say is the graph of this is a vertical translation of the graph of f of x. Hence, the two graphs should have the same arc length. We can explicitly establish this, and we just did it. But they were exactly the same. Okay. Number 5. use the formula for arc length to show that the length of a graph over 1 to 4 cannot be less than 3. Use the formula for arc length. Length of graph 1 over 4 cannot be less than 3. So the picture, I think, makes it pretty obviously the let's see. Yeah, if f prime of x, the minimum value it could be would be 0, right? And f prime squared would be 0. And 1 plus 0 would be 1. So, yeah. The minimum value that could be number 1, because f prime, let's see, f prime, you're going to square it. So the minimum value that could be would be 0. And if you carried it out from there, you would get exactly 3. So I don't know, since the square root of x squared plus f, the square root of 1 plus f prime squared is greater than or equal to 1 for every surface function, then just do it over the 1. You've got to exceed that. Yeah, they say the same thing we did. They just went about it a slightly different way. Okay, homework exercises here. Do either 1 or 3 or both, any of the odds 5 through 9, any of the odds 11 through 15, do any of the odds 17 through goodness gracious, through 33, I believe it is. Okay? Then do any of the odds 35 to 41. And they say you need a computer algebra system. I don't know if you will or not, but try 43 or 45, or both if you like. Then any of the odds 47 through 50, no, 47 or 50, or 49, either of those. Okay. Then further insights and challenges, just look at those to see if there's anything special there that you might be able to find as a paper topic. The only thing I see is Riemann, which certainly you could have had any time in the past as well, so nothing new there. All right, that done, now we can move on to (8.2). Wait a minute. Why is it giving me this? We can't save that because the file is read-only. Well, don't save it then. I didn't ask you to save it. Ugh. Okay. Whoa, yuck, I messed that up. All right, 8.2. All right. Hey, same picture even here. Slideshow from current slide. Okay. Oh, that's right. I was going to say, we've only been recording 30 minutes. I forgot. I messed up earlier. Okay. I was going to say, something screwy here, and it was me. Okay. No, it's not quite the same picture. Close, but not quite the same. All right. Since water pressure is proportional to depth, divers breathe compressed air to equalize the pressure and avoid lung injury. Okay? That is definitely true. Are either of you divers? Read anything about diving? It's a pretty interesting field. I'm not one either, by the way, but as long as you're making shallow dives, there's really not too big of an issue there. But when you're making pretty deep dives, usually your body adjusts pretty well going down. But what's that? Well, yeah. Did you say it depends, or that's the bends?
That's the bends.
The bends. Yeah, I was going to say that's called the bends, but I couldn't understand if you said that to begin with. That's definitely part of it. The other part is your blood has gases dissolved in it. You know, of course, oxygen, carbon dioxide, and all that kind of stuff too. So, and nitrogen's in your lungs too. Everything is there. If you come up too fast, since the pressure increases with depth, you come up too fast. Going down, most of the time you adjust to it okay. But coming up, like you say, with the gases in there, because Charles's law that the pressure and volumes are inversely proportional to one another, right? That if you increase the pressure, you decrease the volume, but if you decrease the pressure, you increase the volume pretty dramatically. And if you think about it, little things either in your lungs, and that's probably where most of it occurs. In your lungs, you have air there, and if you come up too quickly, then the air that in your lungs suddenly is a lot bigger volume. Your lungs aren't any bigger, but then, I mean, you can start hemorrhaging, and you could be dead.
They say your lungs shrink.
What's that?
Your lungs shrink with it.
You want to
Shrink?
The pressure in your chest is deep.
I was hearing something about some guy made a dive without any oxygen,
Right.
It was like long stuff. And by the time he got to the bottom, he was so far out of air.
Oh, yes. Oh, your lungs shrink is what you say. Yeah, exactly.
Shriveled up so
Yeah,
small.
because the pressure, decreases that big time.
Did you ever see something about like when they teach submariners to escape submarines? Tell them to like completely exhale and then jump out, because by the time you get to the surface, your lungs will have reinflated from the lack of pressure on them. Because they're in the submarine, they're sitting at the atmospheric pressure almost the same as the depth of the water, which is like say several hundred psi at that point.
Right.
So.
Were you saying jumping out of a plane?
No, submarine. So I remember seeing the thing about they were teaching submariners to escape the submarine.
Oh, right.
They would completely exhale and dive out. By the time you get 100 meters to the surface, your lungs would completely reinflate.
Right. Just by expansion of the gases, residual gases there. I don't know, since we have fairly little time, I think that's Charles's law, the volume. I don't remember. I get all three of those names crossed up. I believe that's the one. The reality of that came, was sort of etched indelibly on my mind when I was in Navy ROTC when I was in college, and we had a cruise every summer, one between the freshman and sophomore summers. So it was our third class midshipman cruise, and then the one between sophomore and junior years was second class, and then the first class was between junior and senior years, and then we got our commission at the end of our senior year. So the second class cruise, one between sophomore and junior years, was a 6-week event. The first 3 weeks we were in in Little Creek, Virginia, amphibious Navy and Marine type training, because that's all part of the Navy too. But then the second 3 weeks were down in Corpus Christi, Texas, at Naval Aviation Training, where they're trying to talk you into going in becoming naval aviators. So we were down there, and the first, and by the way, this is a little bit of history for me. My very first plane flight ever was when they flew me from Little Creek, Virginia to Corpus Christi, Texas, in an naval transport plane, canvas seats facing backwards. It was not a luxury flight by any means, but that's the first time I'd ever been off the ground. You know, I had taken, we'd ridden in cars, trains, and buses, and things like this. Never taken a flight before then. Okay. I'd even been across the Atlantic in a ship and back on my third class midshipman cruise. Never been in a plane before. So we got there to Corpus Christi, Texas, and after barely one day of class, and what to do in that, because there were so many of us there, lots of different schools were there, and they had to split up the 3 weeks, and you had to get all your flights in, and we just happened to be in the first one. So in that first week, we had to take our 5 hops, they called them. And the first 3 were in a T-34 single prop trainer, and so my second flight ever was like the day or two after my first flight ever. I was in the front seat of a thing and supposed to be flying. Okay. Of course, the first day was general orientation, so the instructor in the back was basically doing everything, just letting me get a feel for it. The next day, third flight ever, I was supposed to be doing the takeoff and landing and all that kind of stuff. Not very good at that, I'll say. The third day, in that same T-34, or similar one, it was to be acrobatics. And so the instructor in the back seat was doing most of it. And we were doing loop-de-loops and barrel rolls and all these kinds of things. And I was wanting, like everything, to use my barf bag and throw up. I just didn't have enough on my stomach. But it was one miserable flight as far as I was concerned. The fourth day, which was then my 5th flight ever, it was in a 4-engine prop plane still, S2, I believe it was. Oh, it felt like a Cadillac compared to a Volkswagen. And that was the most fun of all the flights. And the guy, strafed the beaches, and saw the people out there bathing, sunbathing and stuff like that. That was a fun time. But then the 5th flight was the last week of that thing, and it was to be our jet hop. Okay, and so on the way out there, we had to drive to a different base. And on the way there, they had us split into 3 groups, or volunteer for any one of 3 groups. A was to be the general orientation flight. B was to be acrobatics. And C was to be a combat hop, C hop. And then the general orientation, and all these, the instructor pilot, I think, was in the front seat, you were in the back seat. But they let you do things on the first 2. I went for general orientation all the way. 6th flight I'd ever been, ever. So I was offered to. Well, when they got there, whoever got the list thought they were in reverse order. So they had Group A going. Well, they started with Group A, and we happened to go on a combat hop, the sea hop. And I was in the back seat, and it was two aircraft going up together. The guy who was just about to finish his flight training, jet training, was, and I don't know if he had an instructor in the back seat. I assume he did. And then the instructor in the front seat, and I was in the back seat of this one. And they said, basically, don't touch a thing. I mean, we're going to be going. And literally, they were having, they would take turns who was chasing who, and they were doing combat maneuvers. And it was, all I could see was the back of the front seat. I was in what they call the Naval Flight Officer seat, who was the navigator, basically. And it was the longest, they said it was about 25 to 45 minutes, the longest 3 hours of my life, it felt like, and I wanted to throw up so badly because, of course, in those, with a jet, you have to have, what do they call it, the straps around you, the bladders, to keep the blood from flowing.
The G-suit,
yeah. Yeah, the G-suits, yeah, to keep the blood from all going to the
your legs.
Right. Yeah, so they would pump up, your thighs would pump up and around your waist, and they said, and when it happens, push against it, grunt, do everything you can, forcing the blood to your head.
Yeah.
So I was in the back seat as he was going through the combat hop, and it was a cloudy day. I don't even see how they did it at all. I couldn't see a thing but clouds.
Radar only.
Yeah, well, that was so close, and so I don't know. My hat was off to him if I had a hat, but it was incredible. I looked, I never could see a thing, so I decided to, what I could see every now and then was the horizon. And it would sometimes be like this, and sometimes the ground would be here, and the sky would be there, and other times would be here, the sky would be here, the ground would be there. It was just, I had no orientation of anything. And I thought I wanted to be in a general orientation thing, just take it easy, take it slow. But no, I was up there. It was incredible. Terrible. It was terrible. And so I decided I'm just going to study the instruments and see if I can follow what's going on with that. So I looked down, and what they call the level flight indicator was a globe. It looked like it was floating in water. I don't know if it was, but it looked like that. Yeah. Probably clear oil or something. But anyway, the top half was white, the bottom half was black, and then there were lines of to let you know your orientation this way and your orientation that way. So I happened to glance down at that, and all I could see was the South Pole spinning like crazy. I did not want to think about what that meant. So I said, I'm not going to look at that anymore. And what it was, we were in a dive and spinning, but we did come out of it. And every 3 minutes, I was because it was just choking me to death. And I couldn't throw up because every time I wanted to, it was choking me.
What plane was it? The double seater?
I'm guessing it was I can't remember. Does A4 have a front and back seat? Or
A4, is that the one that's usually called the ugliest plane ever, big intake on the bottom? And,
I can't remember that, but it was one front and back. Others had side to side. This was front to back.
Yeah, A6 is bigger, B side to side, and extruders be vendors.
It's been so long, I don't remember. I believe it was A4. But anyway, finally, and when we landed, I really did want to kiss the ground. I mean, I wanted to so badly, but not in front of it. Because I would have thrown up and down. Well, number one, we were the first group out, so we hadn't had lunch. Okay. The others, meanwhile, had been, and I was later very thankful for that. Though I was starving by the time I got back because they had the garbage bag. And there was my box lunch of good old greasy fried chicken, and it was a good lunch, really great lunch. But this group C that thought they were going combat hop, that's where all the jet jockeys, they had wanted to get in that. And this guy found out that he was in general orientation. No, I want to be in. He said, look, those are already happening. You're not going to. But I went out in, and the kid was a nice kid. He was in our class. He pitched a fit. And he got the instructor pilot so angry at him. He said, "You wanted a Seahawk? You're going to get a Seahawk." So he was in the back seat, and this guy took him probably far worse than what I had been through. And I'll use his first name only, Greg, and he had just had his greasy fried chicken and pull-ups and stuff, and took him through all that. And I guess about halfway through it, Greg, the barf bag came in really handy for him. But he was so embarrassed because they had not gotten along well, and he was in the back seat throwing up, so he was doing this as quietly as he could. And when he finished, he tightened down that bag so that none of the odor would come out. He was just going to hold the bag until they got down on the ground again. But unfortunately, he was right at the bottom of the dive when he was holding the bag. And then they went into a climb, and he didn't pay attention to the bag. And as they climbed, the pressure in the cockpit, of course, decreased, but the pressure in the bag was constant. And it started blowing up like a balloon until it exploded like a balloon. And the pilot's already angry at him, and giving him the roughest time possible, said, "What in the world are you doing back there?" Because puke was all over the cockpit. All over.
As soon as he started going to the dive and the zero G started to flood everything, that was the worst.
And so when he came down, Greg was coated with it. He was in a bar flight suit, of course. We didn't have flight suits, but we had to be in one. And he was required then, green behind the gills as he was, to go in with Q-tips and clean all the instruments and everything else in the entire cockpit. And finally he came in, and we were in an upstairs room, and windows were open. It was summertime and stuff. And all of a sudden, everyone in the room said, "What is that smell?" It was just awful, almost like a septic tank coming toward you. And Greg walked into the room, very sheepish looking, still somewhat green behind the gills, and we got the story of what had happened. And so I remember Charles's Law very, very, not fondly, but well from there. Sorry about that. I shouldn't have taken the full time for that. We'll begin here next time right at basically 8.2. We didn't get anything done there. All right, sorry about that.